I'm Ashutosh. I hope that you are fine. Okay, and we are going to learn the first chapter of class 10th, which is chemical reactions and equations. We will be knowing the what are the chemical reactions. Okay, what are the changes. Okay, which we can say that now this chemical reaction has happened. Okay, and then we will learn that how to write the chemical reactions, what are the various properties of writing a chemical reaction, okay, a chemical equation, okay, and everything about reactions and equations. What are the different types of chemical reactions and how we are going to you can say understand or recognize that which type of chemical reaction this equation is representing. Okay, so let's start. Okay, so as I said, I am Ashutosh and I am going to teach you chemistry. Okay, and we will have a kind of fun learning chemistry. So let's start with this. I'm going to share my this presentation. Yeah, so I hope that you all can see uh, this page. Okay, so we are there'll be like a series of lectures. Okay, so this is lecture 1 of the whole series of lectures on this chapter. Okay, so chemical reactions and equation. Let's start. So our what are the topics which we are going to cover in this lecture? Okay, so we'll have a kind of introduction that what are the chemical reactions and when we'll say that chemical reaction has happened. Okay, then we'll write the chemical equations. We'll learn how to write the chemical equations and all. Then we'll be dealing with the characteristics of chemical reactions, that what are the properties, what are the characteristics of chemical reactions, and then limitations of chemical reactions. Okay, like there are certain limitations and how we are going to remove these limitations, okay, by using proper symbols for showing the state of the matter of the reactants and products. Okay, so let's start with this. So first we'll have a like introduction. So introduction, when there's a change happens. Okay, whenever there's a change. Okay, so then we'll say that this change is either of physical form or chemical form. So if physical changes, like in physical changes, what happens, the uh, composition will remain the same. Okay, let's take one example of that. Let's start with water. Okay, so let's say we have H2O. Okay, so we all know water is H2O. Now if I say that there are two atoms, hydrogen and hydrogen, two atoms are bonded to one oxygen. Okay, and that's how this H2O one molecule exists. So this H2O represents one molecule of water. Okay, why I am writing this and why not like this? Okay, you will learn this in 11th class. Okay, so this is one molecule of H2O. Okay, this is one molecule of H2O. Now there will be like different molecules of H2O. Okay, many molecules of H2O, like this we can say. Now when these molecules are closely placed like this, okay, let's say like this, okay, well arranged, so like very near to each other, so then we'll call it as solid form or not. What I am trying here to explain is all these will have H2O. So this is one H2O, this is another H2O. So like this, there are different H2O molecules. Now, when they are like away from each other, there will be like more distance. Okay, so then we'll call it as liquid or not. But the composition, the molecular composition will remain same. So H2O and H2O. So that it was H2O and it is H2O. Okay, so then let's say we'll have a different condition, then that the distance is even m- more more than the liquid case. So then we'll call it as gaseous or vapor. So it means that when let's say this is ice, this is one some ice, okay. So when ice melts, okay, so then it gets converted from solid to liquid, and when we heat it further, so then all the liquid will get, you can say, change to gaseous form, okay. So this all the change in state is a physical change or not, is only a physical change. Why? Because the composition, it's H2O, it was H2O before melting, like in form of ice, okay, and it is H2O after melting, okay, in form of, let's say, water. Correct. So it means that it was initially H2O, and after melting it is also the molecule is H2O only, and that's why we'll say that uh, the composition, the internal, you can say, arrangement of atoms is not changed. What has changed? Only the distance between the molecules, different molecules. So these type of changes are called physical changes. Physical changes, I hope you are getting it. Okay, then what happens, let's say we have some, so like any process that involves the rearrangement of structure of the substance or conversion of reactant into products is defined as chemical reaction. So what does this mean? Let's see some example. Okay, like this. Okay, what happens? So we all know about photosynthesis or not? We all know about photosynthesis, huh? So in photosynthesis, what happens? Let me uh, explain this in detail. So in photosynthesis, what happens? We have this CO2 coming from, sorry, yeah, let's see here. Yes, so CO2 plus water with in presence of sunlight. So we can write it as CO2 plus H2O. No, I thought that you people, I don't know whether you know photosynthesis or not. I think सब लोग जानते होंगे. खैर, so CO2 plus H2O in presence of sunlight, okay, and then we'll get here uh, some complex compound, let's say C6H12O6 plus O2, okay. Here we can say carbohydrates plus oxygen. So carbohydrate, this glucose is also a carbohydrate, so that's why we can say carbohydrate plus oxygen, this oxygen. Now see, initially it was like carbon was associated or combined with oxygen or not, and hydrogen was combined with oxygen. Now both the carbons and hydrogens are like now arranged in a different fashion or not, okay, and oxygen is also like now free, connected or bonded to only oxygen. So it means that initially, or let's take another example like N2 plus H2, okay. So it was N2, N atom was associated with another N atom, H atom was associated with or bonded with another H atom. Okay, now they are, both of these reactants, these are called reactants, huh? Reactants, okay, and this on the other side of the arrow will be product, products. Okay, so these are the products of this reaction, okay, and this whole thing is called chemical reactions, okay. Let's, so like burning of wood is also a form of chemical reaction, okay. Now let's see, burning of magnesium in air to form magnesium oxide. What happens? We'll have a magnesium ribbon, okay. So magnesium is a metal, and magnesium ribbon is very you can say flexible kind of ribbon strip, magnesium strip, okay. So like hold it with a pair of thongs, and then pair of tongs, and then this magnesium ribbon is like burning of magnesium ribbon, we can say. But actually what is happening here is Mg is reacting with oxygen, okay, and it is going to form MgO, magnesium oxide. This is white powder substance, white powdered substance. Okay, magnesium oxide, you can see this. So this magnesium ribbon and then pair of tongs, and then this is burner. So magnesium ribbon being heated over a burner, then what happens, this burning of magnesium ribbon happens, and we'll get magnesium oxide as our end product. So finally what is happening, this magnesium is reacting with this oxygen to form MgO. Okay, clear? Okay, next. So this is a kind of chemical change, and that's why all the chemical changes are called chemical reactions. Simple. Chemical changes are chemical reactions. Okay. So now writing the chemical equations. What are we going to write or represent by a chemical equation? See, when we say equation, it means what? It means that the left hand side will be equal to the right hand side. Left hand side, right hand sides are equal, and that's why we'll call it equation. Okay, so math, we know that we have mathematical equations like 2 plus 2 is equal to 4, like this. So it means that on the left hand side we'll have something, and on right hand side we have a different thing, and but both are equal. Okay, and that's why it is called equation, mathematical equation. Similarly, we'll have chemical equations like this. Let's take example of this reaction. So we'll have N2 plus H2, and it will form NH3. Okay, now see, we took two two atoms of nitrogen here. Okay, but here only one nitrogen atom is present. Okay, so we can balance it. Okay, we will learn it, but let's see here that it was present as nitrogen. Okay, and this hydrogen was present as hydrogen, so we'll call it nitrogen, and we'll call it hydrogen. But here we are not going to call it nitrogen hydrogen. Okay, we are going to call it ammonia. So it is a totally different compound or not, substance or not. Okay, it will have a different properties, or very different than these substances. Okay, so let's take one other example like H2 and O2. So we know that H2 is very highly inflammable gas. Okay, it catches fire very easily, and oxygen helps in burning. Okay, in combustion. Okay, you can say. So these both are where these two are there, so it will be, you can say, fire will be there or not. Okay, because hydrogen, okay, catches fire easily, and oxygen helps in fire. But when they combine with each other, they'll form H2O, which is, we can use it as fire extinguisher or not. Okay, it is not going to help fire. Okay, so that's how this, we can say that the property is totally changed or not now, because it was like initially gas, and it was also gas, but when they combine with each other, so it is going to have a liquid state at room temperature. So gas at room temperature, we can say at room temperature, while this is liquid at room temperature. Okay, so it means, okay, so it's like that after chemical reaction, some new compound will form, some new substance will form, and which will have a set of properties which is totally different from the properties of reactants. Okay, like this we can say. Now next, so let's see here the method of representing. So what are we going to represent through chemical equations? We are going to represent the chemical reactions by use of different symbols, okay, and different formulas of compound. Okay, so the method of representing a chemical reaction with the help of symbols and formula of the substances involved in the reaction is known as chemical equation, like this. Okay, so we have this zinc reacting with sulfuric acid. Okay, so what happens, zinc sulfate and hydrogen is formed. Okay, and see the equation is given as zinc, we can represent zinc with Zn. The symbol of zinc element is Zn. Okay, and sulfuric acid, so we have H2SO4 as the chemical formula for H2SO4, sulfuric acid. Okay, and then they both are going to react with each other. Okay, so we can write the conditions here, we'll learn it. Okay, and then zinc reacts with this H2SO4 to form zinc sulfate. So we can write it like ZnSO4 plus H2. H2 evolved. Okay, so like this we can write the chemical equation. Now explanation. There are like certain things which we can add, or you can say, to improve the representation of chemical reaction. Okay, these are the tools to, like like in the previous reaction, in which state this zinc exists, in which state, liquid or solid or gaseous or aqueous, you can say. Okay, aqueous means dissolved, huh? So when something is dissolved in water, it will be called aqueous state. Okay, so zinc, we can write that zinc here, we can take zinc as solid zinc. Okay, and H2 evolves as gaseous, okay, gaseous hydrogen. So we can write like the states of these different reactants as well as products. Let's see. Okay, so the equation which gives more information about the chemical reaction is known as informative or information giving equation. Okay, the chemical equation can be made more informative in three ways. Three things we can, you can say, write while writing the chemical equation for any chemical reaction. Okay, by indicating the physical states of reactants and products, like here. So we took Mg was solid, so we can write S here. Okay, then this O2 was gas, so we'll write gas here. And then MgO we are getting as solid, no, white powder. So like this we can write by indicating the heat changes taking place in the reaction. Okay, like we are providing some heat. Okay, providing some heat, no, because Mg is heated. Okay, so represented by delta like this, it means heat. It means heat. Okay, and so what are the heat involved in the chemical reaction? We can write it along with the different symbols and formulas of chemical compounds, to, okay, to having like, we can say, have a more informative chemical equation. Okay, then third is by indicating the conditions under which the reaction took place, like here, see, here we wrote the condition there, na? This H nu and this sunlight. So okay, at the upper side or lower side of arrow, we will write the conditions under which this reaction is possible. Okay, otherwise this reaction will not happen. Okay, so and then we'll write, like here we have CO2 as gaseous form, H2O as liquid, we can write. Okay, let me change the color of this. So this was gas, this was liquid, we can write, and this sunlight, and this is solid, and this H2O2 is gaseous. So like this we can uh, write the chemical equation, and more informative, with more information, you can say. Now, characteristics of chemical reaction. How are we going to know, or okay, say that a chemical reaction has occurred? So first thing is that some new substance will form. Okay, like here in all the chemical reactions which we wrote, okay, some new compound is being formed. Here see, MgO is, it is a new compound. Okay, it was not there present initially. Okay, this glucose, it is also a like new substance, huh? And then see, ammonia, so it was not present earlier. Okay, only N2 and H2 were there, and now NH3 is formed, and that's why we'll say that when new compound is formed, then we'll say that chemical reaction has occurred. Okay, then characteristics of chemical reaction: change in color. Okay, like potassium dichromate solution is orange in color. Okay, and when sulfur dioxide is passed through potassium dichromate solution, the orange color of potassium dichromate solution changes to green. Okay, so let's watch one video, okay, where potassium permanganate is reacting with citric acid. Okay, so I'm going to play this. So here water was there, and then potassium permanganate is mixed. Now stirring is done, so to have an like uniformity, so uniform color, okay, all throughout the volume of the solution. Now we are going to add citric acid. Citric acid, like we can take some lemon and so it's time lapse video. See the color change is happening or not? Hmm? After a few minutes, the solution becomes completely clear as pure water. Okay, where this color of potassium permanganate like disappeared. Okay, see, so this was one reaction where a new substance was formed. Okay, let's take another. So change in color and some new substance formed. Okay, now next, evolution of gas. See here some gas is evolving, here also some gas is evolving, like in the given example, in the previous example where zinc was reacting with H2SO4. So how will it come to know that reaction has occurred? Because ZnSO4 plus H2, when we bring some you can say candle, okay, so near this H2, okay, so it will, the candle will get off with a what pop sound, we know this. Okay, so this is a confirmatory test of that H2 is being evolved, and that's why uh, we can say that zinc when reacts with this, so by when a gas evolves, okay, so that's how we'll come to know that some reaction has happened. Okay, let's take another example. Okay, so next is, okay, so this video, let's take, formation of new substance. Let's see.
Hello scientific people, how are you today? So today I'm going to demonstrate a precipitation reaction, and I'm going to perform the precipitation reaction between lead nitrate PbNO3 whole twice and potassium iodide. Both of them, they are white colored salts, and what else do we require is we require few test tubes and some water, right? So let's begin the experiment, and then we are going to go inside the details of the reaction part. So first of all, I am going to take some lead nitrate, that is PbNO3 whole twice, very pinch of it,
Very small amount, very small amount.
and I'm going to place it over here. Then the another test tube, I'm going to add potassium iodide, that is again a white color salt. Now in this potassium iodide, I'm going to add water so that this becomes the aqueous solution of potassium iodide. Now this is PbNO3 powder, lead nitrate. I'm going to add water in it. Shake it well. Now PbNO3 whole twice this is the aqueous solution. This is the aqueous solution of potassium iodide. Now all potassium compounds are soluble in water and all nitrates are soluble in water. Now you can add any of these solutions into one another. There you go people, fantastic. So here as you can see, that the precipitates have formed and the precipitates are yellow in color. Now let's find out from the reaction that which is this yellow precipitate over here. So here is our reaction. Potassium is K plus 1, iodide is I minus 1, Pb is plus 2, NO3 is minus 1. So now the reaction is going to happen, and this is a double displacement reaction. Both the positive ions are going to get interchanged. So we get PbI2 plus we get KNO3. Now we know that all compounds of potassium are soluble in water. So that means KNO3 dissolves in the water. So we have water in it and KNO3 is already dissolved. So that means the substances that does not dissolve in water forms a precipitate. So PbI2 precipitates which are yellow in color, and I should let it settle down for at least an hour so that we may see the precipitates in a very better way. So hopefully guys you have enjoyed my explanation. Please do subscribe to my channel, and thank you for watching the
Okay, so it was you can say color change or precipitate formation is also you can say that chemical change has happened, or whenever we'll observe some evolution of gas, change in color, and this precipitate formation. Okay, now release of heat. Okay, so like in when uh, combustion occurs, let's say wood burning or any, okay, burning of wood or anything like fuels, any fuel, so we'll get some heat or not. Okay, evolution of heat occurs. So this evolution of heat represents that or tells us that some chemical change has happened. Okay, like in the formation, like wood, burning of wood is a like very good example of this. Next, formation of precipitate, so we already have seen it. Okay, so this is how we can say that chemical reaction happens. Now, characteristics of chemical reaction: absorption of heat. Okay, so whenever absorption of heat is there, we'll call it that there might be some, you can say, reactions or, okay, so only not only a physical uh, change happens, okay, by absorption of it, but in some cases or in most of the cases, you can say, in chemical reactions will be supplying the heat and then the change of the substance will occur. Okay, the composition of the substance, like evaporation here, these are the chemical reactions. Okay, so then next is change in state. Okay, like here melting is happening. So burning of candle is uh, you can say a physical change or a chemical change. It is both actually. Okay, so when we light a candle, so due to heat, now what happens? So there is like this wax is present. Okay, and this wax is going to, you can say, have a combustion reaction. Okay, it will react with oxygen, and so this wax is going to you can say react with the oxygen present there in air and will form CO2 and H2O. Okay, so now so we can write wax plus oxygen, then arrow, then CO2 plus H2O plus something and plus heat. Okay, plus heat. So this heat is also going to, you can say, evolve in this reaction. Okay, now this is one thing. So it means that this is a chemical change happening there. But by this heat, by this evolved heat, this wax is also having some melting of wax or not, we'll observe. Okay, so this melting of wax is a chemical, not a chemical change, it is a physical change. Okay, so you can say that burning a candle has both of these reactions or both of these changes, that is physical change as well as chemical change. Okay, so now limitations of chemical reactions, like in a limitation in chemical reaction. okay, will not be able, like while writing, while representing the substances by symbols, will be like unable to like know that whether this zinc is present as solid or liquid or gaseous. Okay, this H2SO4 is also present as a salt, or okay, so like in crystals, or or in solid form, or in liquid form, or in which form. Okay, this zinc sulfate is a salt, so it is present as crystals, or in liquid form, or in aqueous form, or in which molten form, in which form. Okay, so it means that physical states of of reactants and products need to be written. Okay, then reversibility of reaction means like when this N2, okay, reacts with H2 to form ammonia. Okay, then some ammonia will also get dissociated into N2 and H2. Okay, so then for these reactions we are going to make this double headed arrow. Okay, like on both side, that this is representing that uh, the reaction is happening for both side. Okay, on both sides, so some N2 and H2 are reacting together to form NH3, and some NH3 molecules are dissociating into N2 and H2. Okay, now conditions necessary for reaction to occur. I already explained that on these arrow we can write the conditions which are necessary for this reaction to occur. Then concentration of solutions of reactants and products, we can write the concentrations or pressure, that at what pressure this N2 is present, at what pressure this H2 is present. Okay, like this we can write, and that's how we can, okay, like this. Then heat changes, as I explained, that we can write the heat involved in this reaction, okay, by either writing plus H or minus H. Okay, like this. Then formation of precipitate, I explained that if let's say we have this reaction, okay, this PbNO32 plus Ki, 2Ki, or we can simply write Ki, okay, here. Then we can write PbI2. So we can write it here like either we can represent the formation of precipitate either by this downward arrow, okay, or by writing PPT here, or by writing solid here. Okay, so like either of this arrow or PPT or solid we can write, can use. Then evolution of gas, I already explained. But these chemical reactions, see, in it means that in chemical reaction, while writing the chemical reaction, how are we going to show that this H2 gas, okay, is formed? Okay, so it means that we have these limitations and time which is, you can say, this reaction took. Okay, so then removal of these drawbacks, so these are like considered as drawbacks of writing a chemical equation. Now, so removal of these drawbacks, we can write the physical states by symbols. Okay, like I already explained. So what are the abbreviations we are going to use? We are going to write S, small s in bracket, if the reactant is solid or product is solid. We can, we'll write L for liquid. We'll write G for gaseous reactants and products. Then we'll write aqueous for salts. Okay, dissolved in water, aqueous. Yeah, these are the abbreviations which you are going to, or symbols which you are going to use to represent the states of reactants and products. Conditions necessary written along the arrow, I already explained. Then concentration are written by writing dilute or uh, concentrated. Okay, like if we, for acids, okay, if we have this H2SO4, dilute H2SO4, so then we will write dilute H2SO4 like this. Okay, like this, dilute H2SO4 or concentrated H2SO4 like this. Okay, then next is heat changes are written by writing plus q kj or minus q kj. Let's see, let's see, if let's say we have a reaction N2 plus H2, and we are adding heat here, q amount of heat, q kilojoule of amount of heat we are adding on the react, it means that we are heating this thing. Okay, and we are getting NH3. Okay, So heat, we are going to write always on the product side. So N2 plus H2, okay, then we can write will form NH3 minus delta Qj, we can write or not, because minus, no, so it means minus means that we are you can say adding the heat, okay, on this side, on the reactant side, okay. And then another reaction we have like H2 plus O2 to form H2O, and then it will have a like very explosive reaction, so very high amount of heat will evolve, okay. So this means this is called endothermic reaction. We will learn these things, endothermic reaction, because here the thermal heat is like, endo means in, okay, so we are adding the heat, and this will be called exothermic reaction, okay. Now let's see, then next, then evolution of gas indicated by arrow pointing upward, exactly. So as I explained that we can use this arrow like H2, this arrow, it means that this is representing gas, okay. And we had this B, not BS4, PBI2 thing, huh? So PBI2, and then we will represent it with downward arrow, means precipitate formed or solid formation occurs, okay. So I hope that you are getting these all, okay. Next is formation of precipitate indicated by arrow pointing downward, yes. Double arrowhead used for reversible reaction, I already explained here, okay. And then rate of reaction indicated by writing slow or fast with products, okay. So rate of reaction we can write like this is a fast reaction, okay, fast reaction, okay. So like this we can write the chemical equations to represent the various chemical reactions. I hope that you enjoyed learning this topic, okay. We'll be coming up with the next lectures and then next lectures and then next lectures, okay, for this chapter, okay, and for the other chapters also. So just thank you for your time, okay. Keep learning from Ask IITians. Thank you everybody.